Hello and welcome to section 11.6. We're going to be finding the area of regular polygons today. It's a fun section. I think you guys are going to like it. I know I do. Here are the answers to 11.5, in case you haven't seen these. I know we had a review day in there, so these should have been posted. And if you struggled with some of those problems, there were the composite solids. I did go over those during our Google Meet, and so if you need to see those, take a look at those on the video that I posted. Okay, areas of regular polygons. So basically what we're going to be doing today is finding the area of a regular polygon. So to do that, you're going to be using some different strategies and techniques that we've learned throughout the year, and which should be a similar pattern for you guys. Basically, the strategy is to take whatever regular polygon that you're working with. All right, let's say you have a hexagon, right? And so here's the strategy: is find the area of one of these triangles here, and then multiply that area by 6 in this case, because there would be 6 triangles and they're all the same because it's regular. All right, and so to do that, what you're going to do is you're going to be using this length right here, okay, and then this length right here, and you're going to do 1/2. Call this x and y times x times y. Okay, now the x is just the side length, y is the, there's a special word for y, it's called the apothem. Okay, so the distance from the center to any side is called the apothem. This is the most important vocab word in this section here. And there's multiple ways of doing this, and so I'm gonna show you guys my favorite ways, but if you decide to do it a different way, I mean, that's okay. There's a lot of different ways of doing this. Keep in mind, since this is a radius and this is a radius, so to speak, if you draw a circle around this, if you inscribe this regular polygon in a circle, these are going to be the same. So you're creating a bunch of isosceles triangles, and that information might also be of use to you. So I'm going to go over finding central angles here quickly, because sometimes you have to use trigonometry or 30, 60, 90s in order to find certain measurements. So it's important that you know how to find a central angle here. So it says in the diagram of a regular pentagon, find each angle measure A, F, B. So they want this one first right here. Well, we have, if I split this up here, there's 1, 2, 3, 4, 5 central angles. So we can do 360 divided by 5. So 360 divided by 5. So that's 72. And then they want AFG next. So that would be, if I erase my disaster here, AFG would be half of that. So 72 divided by 2. And then GAF. So they want this one right here. Well, if this is 90 and this is 36, then this would be 54. So these angles, specifically this 36, that angle right there, will help you potentially find pieces or side lengths that you're looking for. So keep those strategies in mind. Okay, let's just get right into an example before I actually show you guys a formula for this. You're decorating the top of the table by covering with small ceramic tiles. The tabletop is a regular octagon with 15-inch side lengths, and the radius 19.6. What is the area? Okay, so what I'm going to do is I'm just going to draw an octagon here, and we're going to label things. So this is 15. If I draw this central angle in here like this, well, it's 19.6, and that's 19.6. I need to find this value here. I need to find the height of this triangle. I'm going to multiply that area by 8, because there's 8 of those triangles. So I'm going to use Pythagorean theorem on half of this triangle. So this would be 7.5, and and this would be 19.6, and then I can find the apothem A right there by using the Pythagorean theorem. So I'm going to split that into two triangles. So I'm going to do 19.6 squared, take away 7.5 squared, and then I'm going to square root that answer, and that leaves me with 18.11 for A. Okay, now if I take a look at the whole triangle, the apothem is 18.11, the base of the triangle is 15, so I'm going to do 1/2 base times height, and then I'm going to multiply that by 8, because there's 8 triangles, and so that's going to be my answer. So 15.1, 15 times, it's a times there, I can't read my handwriting. So 15 multiplied by 18.11 times 8 divided by 2. And my grand total is 186.6. So there you go. Now, I'm going to show you another method of doing this. Here's what we got going on. What we've been doing is we've been taking the area of one triangle, multiplying it by the number of triangles. Okay, so if we take a look at this guy over here, we have the area of one triangle, 1/2 base times height. That's the first thing I did. And then the second thing that I did is I multiplied that by the number of triangles. So that's exactly what I just did here. I have one triangle times the number of triangles. Okay. Now, if you rearrange the terms and you put n times s together, well, if you take the number of sides times the side length, this is really the perimeter. So you end up with this formula, 1/2 apothem times perimeter. Now, they also give you 1/2 A times NS, but this is like the go-to formula. This is the easiest formula to use. It's like a shortcut. So if you know the apothem and you can find the perimeter, you're done. And that's what I'm going to try to use as many times as I can. Like I said, you can find the area of one triangle multiplied by the number of triangles. That works just fine. However, I like 1/2 AP. It's really quick. A regular nonagon, so nonagon meaning 9 sides, is inscribed in a circle of radius 4. I find the perimeter and the area. Okay, so if I find the perimeter, then finding the area is really easy. So let's first find, I'm going to draw, I always draw just one of these triangles out, so 4 and 4. They don't give us much information here. So this means we're going to have to use trigonometry. I'm 90% sure, 99% sure. Yeah, so what I'm going to do is find a central angle here. So 360 divided by 9 is 40, divided by 2 is 20. So this angle right here is 20. And I'm going to start by finding, they want us to find the perimeter first, so I need to find that segment there. So I'm going to call this x. And opposite and hypotenuse, so sine of 20 equals x over 4. Multiply both sides by 4. Okay, so we have 4 times the sine of 20. And that leaves me with, now you might say, what should I round to? I'm going to use thousands for this, just to be as accurate as I can be. So this is 1.368. I'm going to double that to get this full length here, 2.736. Okay, so that's one side of my nonagon, and then I'm going to multiply that by 9 to get P. So now I have P, the perimeter. So the perimeter is 24.6254, so 625, if I try to keep this to be as accurate as I can. Now, I have the perimeter, I gotta find the apothem, and I can do 1/2 apothem times perimeter to get the full area of this nonagon. So I already know that I can use this triangle again right here, and I'll call this Y right there, or I actually should just call it A because it's the apothem. I'm gonna use the Pythagorean theorem. I know this is 1.368. And do 4 squared minus 1.368 squared. And then I will square root that answer. And that leaves me with the apothem being 3.7587, so 759. Okay, and then we'll do 1/2 AP to get the area. Now don't get the little a mixed with a large A, meaning area. They are two separate variables. Okay, so 3.759 times 24.625. That will be the full area right there. That is. Okay, a few more practice problems for you guys. Let's see. I'm just gonna go for 1/2 AP on all these. See if I can do that. Here I need to figure out that value is there. So that one you can just do the Pythagorean theorem on, because I have the apothem. Little a equals 6.5, but I gotta find the perimeter, which means I need one of the side lengths. So I'm going to do 8 squared minus 6.5 squared, and then square root that answer, and that is 4.6636. So I'm going to put 4 there, and then I'm going to double that to get the full side length, 9.327. So we're going to do 1/2 times apothem times the perimeter. Oh, I gotta multiply that by 5 to get the perimeter. So that times 5 gives me the perimeter. P equals 74.619. And this right here is going to be your answer. And again, you may approach this a different way. You might just find the area of one triangle, multiply it by 5. That's totally cool. This one here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a decagon. Okay, that's good to know. 10 sides. They give you one side length here. 7. So I can find the perimeter. Perimeter equals 7 times 10, which is 70. However, I need to find the apothem. And then I can do 1/2 AP. Okay, so the only thing I know is this is 7. Now, oops, that's not 7. This is 7 down here, which makes this 3.5. So to find the apothem, A, right there, what I want to do is use trigonometry. So the central angle is 36 degrees. So that would make one of these angles 18 degrees in here. So I have 18 degrees for that angle there. I have 3.5 for that there. I'm looking for A, so that would be tangent. So I'm going to use tangent of 18 equals opposite divided by hypotenuse. I'm going to multiply by A and then divide by tangent of 18. So I end up with, if I multiply by A and then divide by tangent of 18, that's what I end up with right there. So 3.5 divided by tangent of 18 is 10.7718. So A equals 10.772 if I round near thousandths. Okay, and now I have 1/2 times apothem times perimeter. And there you go. Okay, one more. I think that's the last one I got. I know these problems take a little bit of time. All right, they give us the apothem. That's great. Okay, so we have A equals 5. So we just got to find P now. So what is P, the perimeter? Well, I'm going to draw my triangle right here. Okay, so I'm looking at this here. I have 5. I'm looking for X. I'm looking for that right there, because if I can figure out what that is, then I can just find the perimeter. Now, let's see. Let's figure out what the central angle is. So 360 divided by 3 is 120. 120 divided by 2 is 60. Okay, so this is 60. Ooh, we have a 30, 60, 90 triangle. Okay, so if I take the short leg and I multiply by root 3, it gives me the long leg. So 5 root 3 using the 30, 60, 90 technique. If I double that, it gives me the full length there, which would be 10 root 3. Now if I multiply that by 3, it gives me the perimeter, so P equals 30 root 3. So 1/2 times 30 root 3 times the apothem, which was 5. So that would be half of 30 is 15, and then 15 times 5 is, the exact answer would be 75 root 3. That's kind of cool. So there you go. Yeah, it looks like a mess, and these problems are a mess, I'm not going to lie to you, because you have to incorporate Pythagorean theorem, sine, cosine, tangent, 30, 60, 90, 45, 45, 90 triangles, basically a lot of our prior knowledge. So, yeah, if you guys have questions on this stuff, stop into the Google Meet and you can go over some of these problems. Thanks for tuning in.